Question 4. Determine Thevenin equivalent at terminals A minus B of the circuit shown in figure 4. The circuit is given in time domain. Please convert the component to phasor domain before solving for required variables. Calculate the Thevenin equivalent voltage VTH. Use source transformation only as an analysis tool. If you use any other methods, marks will not be assigned even if the value calculated is correct. Honestly, you shouldn't even need to be told this. Source transformation is incredibly useful. It simplifies a lot. So, let's start. So let's first start by converting this circuit into phasor domain. Oops. Phasor domain. Okay. So, oops. IS is given there. And that is our only source. So, our omega is 1500. And the phasor of this here is 32. So, in phasor, this is going to be 2 with a phasor of 32 degrees. Right? You copy over the magnitude and you copy over the phasor amount. Or the offset, so to speak. Now, we need to convert all of these into impedances, or reactances. So to do that, we use the formulas that the impedance of a capacitor is 1 over JWC, and the impedance of an inductor is JWL. They're inverse of each other. Remember, capacitors and inductors, they do not agree on anything. They're always opposite of each other. So, let's do that. This here, 5 millihenries, that's going to be J times W, which is 1500, times the capacitance, which is 5 times 10 to the negative 3. You get 7.5 J. This is 12 millihenries. Let's do that as well. This is 18. 18 J. This is another one at 2 millihenries. This is 3J. And this here is a capacitor. So that's 1 over I times omega, which is 1500, times the Fahrenheit amount, which is 100 divided by 3 times 10 to the negative 6. W or omega is going to be constant for the whole circuit, right? Yes, you won't be given circuits of multiple frequencies. That makes things insanely hard. Or we haven't even been taught it anyway, so I don't know how hard it is. So, superposition. Oh, that's true. You could just do superposition. I forgot about that. I completely forgot about that. I haven't seen that on anything, but okay, yeah. If you do, you have to use superposition. Your quiz was that? What the? I'm sorry, man. I don't know who the hell is your TA, but man, you had to do superposition on your quiz for multiple. Okay. Point is, if you have differing omegas, you have to use superposition. However, we only have one source here, so we don't need to worry about that. And automatically, if it's given everything in phasor domain, then automatically it's going to be no, this is 18, sorry. It's automatically it's going to be the same frequency. 18. This is 7.5. So, use source transformation. So, can we use source transformation? This is in a current source in parallel with some impedance. So we can. Let's put these into a single block, right? So this is going to be a single block of 15 plus 7.5 J. So we can think of it as one load on the circuit. And so Remember that V is equal to IZ. So that's going to be the current, which is 2 with a phase of 32 times 15 plus 7.5 I. Oops. Let's put that into polar form. And you get, we have to redraw this entire circuit now, 33.54 with an angle of 58.56 degrees. Comes up here. Our load is now placed in series. So that's 15 plus 7.5 J. We have another load in series, right? That is 25 plus 18J. Yeah, I can't draw for the life of me. We have our dependent source here. So this is a negative, this is positive, 20 IX. IX is flowing this way. We have another load here. This is 10 minus 20J. And we have another load here. Lots of loads. This is 30 plus 3J of our Thevenin load here. This is A, this is B. Connect all of these up. Does Favitzer form sign change based on passive convention or nah? I'm not sure what you mean by that. Impedance isn't in phasor form at all. Or impedance isn't in passive convention or not. Impedance is just the impedance over a circuit. This is how to convert Henrys to imaginary units here. 1 over JWC. The alternative equation is negative J over omega C. Those two are the same thing. If you put in your calculator, 1 over J is equal to negative J. So yeah, passive convention only applies on what do you call it? Voltages. Oh, by the way, in this case, terminals A minus B. So A is going to be the positive terminal, and B is going to be the negative. But that's pretty obvious. This is the ground here. So now we need to find VTH, the Thevenin equivalent voltage. So that is, what is the voltage at A minus B? So voltage A minus voltage B is equal to, it's our voltage Thevenin. We don't have more than 2 sources, so this is going to be, there's no superposition here. So let us simplify this circuit. I'm going to pull that up. Let's move that to the side so I can grab everything here without. Immediately we can combine these 2 loads because they are in they are in series. So that's going to be, just make sure I'm recording. I'm getting paranoid after what happened last time. 15 plus 7.5 J plus 25 plus 18 J. So that is 40 plus 25, 25.5 J. If you convert both parts in phasor, could you combine both inductors and capacitors? Yes. They add. Remember, impedance just adds. So if you have an inductor here of 5J, and you have a capacitor here of negative 5J, this is equivalent of an open circuit. However, you cannot do this if they're not in this form. They need to be in phasor form. They can't be in time form. As far as I'm concerned, I don't know how. There's probably a way to do it in time form. I'm not aware how to. I don't think we're expected to. So, now the second thing that we can do to reduce this circuit, right, is recognize that there's no current running through here. There's zero current. And remember, the rule is that when zero current, is VTH not VA plus VB? No. The voltage across any, if you have anything here, and this is positive and this is the negative end, and this is your V, delta V. Delta V is equal to the positive node minus the negative node. Is this only one source? Yes, there's only one source in here. Can you scroll slightly up? Yeah, sure, here. So, the second thing that we can do to simplify this circuit is that we have zero current running through here. And the rule is that when zero current is at 18J, yes. When zero current is running through a resistor, it has zero voltage drop. The voltage drop here is 0. And if the voltage drop here is 0, this might as well not exist. So we can simplify and cut that out entirely. VTH would be the same voltage as the voltage across the 10 minus 20J. So, yes, actually, exactly, yes. That's what I was about to get to. So, this entire node here is VA. This entire node here, actually, this entire node here is VB. So, we can simplify this circuit even more. 30, actually, let's just copy it. Why that's a closed circuit again? It's a closed circuit. Okay, if you have any impedance, so this is your Z block. If the current running through it is 0, then the voltage running through it is 0. It might as well not exist. That's it. Yeah, because it's already an open circuit. So there's no current running across. There's no voltage difference. Okay, so let's simplify this circuit even further. Again, you don't need to, on a test, realistically, you'd probably just be erasing over and over, drawing and erasing, because you don't have time to actually go through it. So now you have this. So you can now find, these two are actually in series. It looks a little bit weird because they're separated by a, actually, no, you can't combine them. You can't combine them. So this is VA. And this is VB. We can't get rid of that because this would be getting rid of one of the voltage nodes that we have to observe. You cannot get rid of voltage nodes that you are observing, obviously, or else you can't observe them. So at this point, you could just do either mesh analysis or, actually, yes, just do mesh analysis. Right? So what is the current running through? Oop. Or you could do voltage analysis. What did I do for this? I did voltage analysis, actually. So yeah, let's do voltage analysis. You will get the exact same answer, voltage or nodal. I did nodal analysis. You will get the exact same answer whether you do nodal analysis or mesh analysis. I just did nodal analysis because it directly gives you the answer. So, oh, I wrote V. Yeah, I was just about to say. Oopsies. So VB is just 0. This is just ground. So actually, we are just solving a single equation here. So let's solve that. This is VA. There's two currents running through VA. There's a current running through here and the current running across. So the current coming up here starts at ground. So that's 0. It comes out the positive end of our voltage thing. So that's 33.54. How do you use Kramer's rule for 1 by 1? The answer is given. Like, you don't need to do Kramer's rule for a single equation. Okay, so it comes across here. We come across our resistance. So that's 40 plus 25.5J. And then we come across our dependent source. So that's going to be plus 20 Ix. Because it comes out the positive end. Is equal to, minus VA. Because it ends at VA. Right? So that's nodal analysis. From ground through the voltage resistor, the voltage source, with a resistance of 40 plus 25.5J, through the dependent source, the dependent voltage source, into VA. So that, that. And we can get rid of 0 here, because 0, is equal to, and again, same thing. We come from VA, minus 0, because that's where we're going to, from minus 2, divided by our impedance, 10 minus 20J. Now, we have to get rid of this Ix. And recognize that this Ix, because it's in series, this is also Ix. So this here is Ix. So now this entire equation becomes 33.54 with a phasor of 58.56 over 40 plus 25.5J plus 20 1 over 10 minus 20J VA over 40 plus 25.5J. Wait, how's the one on the right Ix? This here's Ix, right? The current comes through here, here, here. It comes out here, 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 here. So therefore, this current here is also Ix. It's a single, there's no branches, there's no parallelism. So the current at any point in the circuit is a current everywhere along circuit. So that minus 1 over 40 plus 25.5J VA is equal to 1 over 10 minus 20J VA. It's a bit of a long equation. Okay, let's see if I did my math right. 33.54 with a phasor of 58.56 over 40 plus 25.5J. Oh wait, I did mine in rect form. Oopsies. Complex. I need to change my calculator. I left it on rect form. 0.707 with a phasor of 26 degrees. 0.04 degrees. So that's that part. Plus, now this is going to be, we can just move the 20 up in there. And we can move VA out. So that's going to be like that, ugly as it is. So that's going to be, on the top, 20 over 10 minus 20I over 40, 40 plus 25.5 I times VA. Polar format. That is 0.0189 with a phasor of 30.92 degrees VA minus 1 over 4. We don't need to change this. 1 over 40 plus 25.5 J minus 1 over 10 minus 20 J VA is equal 0. Again, it's just nodal analysis, right? Now we collect the oops. See, I make silly mistakes. We collect the VAs and we move the constants to the right side. So VA here is going to be 0.0189 with a phasor of 30.92 minus 1 over 40 plus 20, is that 25? I can't read my own writing, man. J minus 1 over 10 minus 20J VA is equal to 0.707 with a phasor angle of 26.04. We don't need Kramer's rule. We don't need matrices. This is a single equation with a single unknown. You should be able to solve this. And watch me mess it up. 26.04 degrees. And on the bottom is going to be 0.0189 with a phasor of 30.92 minus 1 over 40 plus 25 plus 25.5 I minus 1 over 10 minus 20 I. Put that in your calculator, put it into polar form. I hate this course. Learn to love it. Learn to love it. So VA is equal to 24.6 with a phasor of 165 degrees. I was like current next to VA. Are we just taking both? I'm not sure what you mean by that. I'm not sure what you mean by that, sorry. Like you got voltage next to current value. Huh? I don't know. I don't know what you mean by that. Do you mean like this voltage right next to the voltage right next to the current or the? Yeah, I don't know what you mean by that. Sorry. I mean like in the equation. Oh, are you asking about this IX? What about it? Yeah, we just substituted in. This is IX because the current running through the entire circuit is the same. It's subtracted by VA. No, this is oh yeah, yes. Just like that. 20 times IX minus VA. How does that work out? You mean like sort of in a sense, or you're asking how does that mathematically work out? Because all we do is we just split it into its denominator. That dependent sources are wild, man. I don't know. I just follow the equations and they work out. I could show you it on MultiSim. I'll show that in a second, right? So let's just do this. So you get 24.6 with a phasor of 165. Is that right? So do we subtract current by voltage mathematically? Yes, it's because it's a dependent source. It creates voltage based on the current running through it. So yeah, it's going to be weird. That's just how it works. I'm not sure what else I can tell you on that front. I may have calculated this wrong. 1 second. Twenty 10 minus 20i over 40 plus 25.5i. $30.92. Yeah, okay. So this is our VA. I'm trying to check if I must have made like an addition error in my math on my previous one, because it's giving me a different answer. Of course it is. What? Same magnitude, but my angle is negative. Okay, yeah, then I must have messed something up. Is that supposed to be negative on the top? Yeah, because my pre-work did get that. Okay, yeah, there's a negative sign missing here. I'm sorry to say you are right. Let me see. Plus 20 IX minus VA. 58.56. 40. Yeah, I did one of the math wrongs here. The math wrongs. 2606, yeah. This is why mesh is greater than Note. Okay, let me just redo this, because you messed up at some point. Yeah, I think I've messed up on every single question so far. That's to give you a sense. Honestly, don't worry about too much. 0.77 with a phasor of 26.04 plus 0.422 with a phasor of negative 32.52 IX minus 1 over 40 plus 25.5 J VA. Yeah, it's just missing a negative. I don't know where I missed it, but I'm just going to do it the same way I did so that I have an actual right answer. So if you extract out, you get this. So that's 20 divided by 40 plus 25.5, so all that fun stuff. And then we substitute for IX in here. We're going to get 0.707 with a phasor of 26.04. No change here. Oh, and then we move everything to the right side. So we get 1 over 10 minus 20 JVA plus 1 over 40 plus 25, 25.5J VA minus 0.422 with a phasor of negative 32.52 times our IX, which is 1 over 10 minus 20 JVA. And again, after this is just algebra. I'm just going to skip all the steps. You know how it is. You collect, you divide. VA is equal to 24.599 or 6 with a phasor of negative 15.28 degrees. Big ... Carrying a lot of heavy lifting there. So, yeah, it's like -2 on the exam. Honestly, not that bad. So, this is our VTH. Because remember, our VTH is equal to VA minus VB, but VB is 0. So, the VA here is 24.6 with a phasor of negative 15.28, yada yada. Terrible handwriting, but whatever. And this here at the bottom is 0. The voltage difference is 24.6 with a phase of negative 15, so on and so forth. That's VTH. And we did that using source transformation. Okay, so that's 1 down. 3 more to go. Calculate ZTH. So, the issue with our circuit here is that we have what is very annoyingly a dependent source. Someone use a soundboard. Who's using soundboard? Don't do that. So that means over here, yeah, it does make sound. We get a test voltage. We're going to call this V test. Is equal 1 with a phasor of 0 degrees. So the reason why is because we're going to get a current coming out of here. Let's call this the I test. And the V test divided by the I test is going to equal our impedance, our Thevenin impedance. So that's our goal. Find I test. We're going to combine these two into and because we're finding VTH, we have to remove all of the sources. We have a voltage source here, so that's going to become a closed circuit. So this is closed circuit. We're going to combine these two because they are in series. Into, what was it? I did before, 40 plus 25.5. J. So this is our circuit. Now there's 2 ways to solve this. Let's solve it using mesh analysis. I did it using a really sneaky method. I literally just source transformed twice over. But let's do mesh analysis because that's probably what they're more expecting. And that's really what you should be doing. Oh, I forgot to put signs on this. Oh no, it was just not showing. So, we have our mesh 1. And we have our mesh 2. Let's do the math. Mesh 1. Mesh 1, let's start from the dependent thing here. So that's going to be 20 IX. Remember that we're finding voltage here. So this is a voltage source, so we could just do 20 IX, or in this case, I1, because this is IX, which is also equal to I1. Then it comes across this impedance, which is going to be negative 10 minus 20J, I1, and it's fighting against I2 here. Then it comes back around to this impedance block, so minus 40 plus 25.5 J I1 is equal to 0. The second block here, so it's going to come out of this V test, so that's 1 minus 30 plus 3J, put that in brackets, I2, it doesn't share it with anything else, minus 10 minus 20J, I2 minus I1, because it's fighting I1 for the current running through here. And that's it, is equal to 0. That's mesh 2. See, that's it. It's real simple. Real simple. Real simple. We only care about I2 actually. So I think we can skip, let's see. So let's just do our standard simplification. Let's simplify this. 20 I1 minus 10 minus 20J I1 minus, or this is actually plus 10 minus 20J I2 minus 40 plus 25.5j I1 is equal 0. We collect terms, as always. So I1, we have 20 minus 10 minus 20j minus 40 plus 25.5j I1 plus I2 now. There's only one here. So it's 10 minus 20j I2. Shouldn't what be negative? No, because what's going on here is you're distributing a negative into a negative. Yeah, it's very easy to make signage errors. So this one, we can actually just use a system of equations. We don't even need to do Kramer's rule, actually. So we can move this to the other side. Let's do is equal to negative that amount. And then we can divide this whole thing over here. Actually, no, we need to isolate for I. Right, yeah. Actually, yeah, we would do the same thing. Never mind. So now we can do that that I is just equal to this amount. Or let's do Kramer's rule because that's the way that we're taught, and that's the way that they're expecting. Okay, let's just solve. I'd rather show you guys like the actual methods because that's what you will be seeing a lot of. I2 minus 10 minus 20j. This is I2 plus 10 minus 20j. I1 is equal to negative 1. I just keep isolating until I have one equation variable. It does work. It does work. Someone added me in general. So we let's collect like terms. So it's negative 30 plus 3j. Alright, let's do I1. Do in order. 20 I1 plus negative 30 plus 3j minus 10 minus 20j I2 is equal to negative 1. Kramer's rule! Who's excited for some Kramer's rule? Come on, everyone likes Kramer's rule. See? I want to see more excitement in the chat. 0, 1. Boo! No appreciation, I tell you. So this here is going to be 20 minus 10 minus 20j minus 40 plus 25.5j. Ooh, I forgot a closing bracket here. Oopsies. So that's going to be Kramer's rule. That's what we're doing. And this here is negative 10 plus 20j. And we pull this here. This is 10 minus 20j. This is negative 30 plus 3j minus 10 minus 20j. Oh, this is negative 1. Oops. This is I1, I2, This is minus 40 plus 17i. Now the nice thing about this is that we actually do not we do not care. Nice words about I1 at all. So all we really care about is I2, which is the determinant 2 over the determinant. Determinant 2 is equal to, let's just assign these the letters. So that's AX, CY. And the total determinant is going to be AB, CD. And then, in the middle of class, you pull out your MATLAB. You are legally allowed to bring with you a phone into the class. Trust me. So all you do is you put in, what's that? So D is going to be the determinant of this thing here, which is going to be minus 30 minus 5.5i minus 10 plus 20i, 10 minus 20i minus 40 plus 17i. Is that 17? That is 17. There you go. See, it's so easy. I don't know why you guys have trouble with this. So it's 993.50 plus or minus 690.0 and the determinant 2, the exact same formula, but we replace the right-hand column with 0 and 1. 30 plus 5.5i. That is going to be 30 plus 5.5i over 993.5 minus 690i. And let's put that in phasor form. Uh-oh. That's not right. Oh my god. See? Dumb mistakes. Yeah, half the people are in the call because I made a dumb signage error and it takes me like half an hour to notice. So there you go. That's a proper written thing. Someone kill me. Anyway. You go up to the top. Let's do the determinant here. So this is the determinant of so D here is going to be 1,593.5 plus 110J. And this here is going to be oh lord. It's going to be -1 and that's going to be, actually I think it's going to be the same. Yeah, it's going to be the same. Okay. Yeah, it's just me figuring out Kramer's rule. So, now we do Kramer's rule, finally. 1593.5 plus 110i, and you will get that the second current is 0.0191 with a phase of 6.44 degrees. So that's our I2. That's our I test. And so our VTH is going to be, or sorry, our ZTH is going to be our VTH or VTest over our I test. Punch in the numbers. We have 1 divided by 0.0191 with a phase of 6.44 degrees. Let's put that into polar form. So it's 52.35 with a phase of negative 6.44 degrees. Ain't that beautiful? God. Okay, so we found our ZTH. Now, calculate the value of ZL for maximum power. So to do this, we need to assemble our Thevenin circuit. So it's similar to DC. You have your plus, you have your minus. You have your alright, guys, with all respect, I understand you guys playing games because I'm fucking up and shit, but you are like filling up the chat. Because I have to look at it whenever someone posts because I have to see if anyone has a question. So this actually is going to be 52 minus 5.87J. So 52 minus 52.03 minus 5.87J. Please screenshot the last two parts and put it in chat, please. Sure. So, it is long. So this is the entire work so far. You'll buy Chipotle for me? Honestly, sure. I have never tried Chipotle. I've been meaning to try it sometime, but I just never did. Anyway, so this is our, what was the value for I test? It was 0.0191 with a phase of 6.44 degrees. So let's copy over, the VTH here. So assembling our Thevenin equivalent circuit. This is our Thevenin equivalent circuit with ZL on the right-hand side. Let's go to the top. Calculate the value of ZL for maximum power. Now the trick here is that the maximum power occurs when so in DC we learned that RL is equal to RTH when the maximum power occurs. This is not true in AC. In AC, RL is actually in AC, this is true, but the reactance is the opposite. So the real part is the same, but the imaginary part is the opposite. So by this rule, right? Let me just write. Max power at this, ZL is going to be 52.03 plus 5.87J. That's our ZL. That's our value of ZL for maximum power. Determine the maximum power absorbed by ZL. By ZL. Sounds like I have an accent. And remember, we did this in question 5. We did question 5 before question 4. That the maximum power is going to be V or 1/2 of VI, or VRMS IRMS. It is the same thing. So what is the current running through here? We can do that really simply. So that's V over Z is equal to I. And substituting that in, we get that the power is Oops, like that. Let me just double check, make sure I'm not finessing here. Okay, here. So it wants the average power, not the apparent power, right? So maximum power, when it doesn't specify, it means average power. So the power average is 1/2 V, the magnitude of V, magnitude of I, cosine of what do you call it? Delta V minus delta I. So unfortunately, we do need to know I. So I, we could just do V is equal IR. So that's V over Z is equal to I. So voltage is 24.6 with a phasor of negative 15.28 over the impedance is 52.03 squared. Because remember, these two cancel out when you add them up. Oh, sorry, that should not be squared. Times 2. Let me just compare that with my work. Yeah. So that's going to be, oops. Put that into phasor form. You get that the current is 0.236 with a phasor of negative 15.28 degrees. So negative 15.28 degrees. Same angle. So actually, this turns to nothing. So you get that P average is equal 1/2 of absolute I of magnitude V magnitude I. Punch that into your calculator. 0.5 times the voltage 24.6 times the current 0.236. You get a whopping 2.9028. This is question 4. What? 24.6, 0.236, yeah. Why are we finding P average? Because it asks us to. It asks to find the maximum power absorbed by the load. Well, I don't know. It's not entirely clear. I think what it's asking for, I would write this down as an assumption. It's asking for the maximum average power that this absorbs. I believe that also would work. I believe I remember hearing that. 24.6. Okay, I think that would be the parent power. To be honest, I don't entirely know what they ask for. It's very unclear in my opinion. But let me try putting it in here. So complex 3. Is that right? What the hell? Okay, never mind. You're right. I must have calculated it wrong. So ignore this. Sorry. The formula is, as given, that the max power is equal to VTH squared over 8 RTH, or ZTH. Actually, just RTH, yeah. You have to memorize that. So just do that. If you put that in, you get 1.45 with a phase of negative 30.56. There you go. And that's the answer. I think that is it. Yeah. That's the last question. That's the last question on the last question of this damn test. Here's your tutorial. Is it possible that after you post a stream, we can ask you questions in chat based on timestamps? For sure. Definitely. I'll look in the comments on both the YouTube and in the Discord. Now we have to do this in only half the time. Half the time? 1/3 the time. So yeah. You have to get used to doing these fast. Again, if you feel like you've made a mistake, just keep going. You don't have time to check over. So that's that. Let's wrap that up. It's 8:45. It's been 2 hours and 45 minutes. So we took the time we're given to do the test in to do 2 questions. 8% from no calculator. All right. Yeah, I'll upload the PDF. I'll do all the stuff. Thank you all for attending and putting up with all the mistakes. I have to go eat dinner now. So after that, I'll start doing the videos and I'll upload the PDF. See you all.